Okay, now you are going to learn how to find the LCM and HCF of any two composite numbers. In the previous video, you learned the very basic concept of fundamental theorem of arithmetic, that every composite number can be expressed as a product of primes or can be factorized as a product of primes, and this factorization is unique. Now suppose for the given numbers you have factorized, okay, by using prime factorization, then what will be the HCF of the numbers or LCM of the numbers? See, HCF is the product of the smallest power of each common prime factor. Product of the smallest power of each common prime factor in the numbers. Suppose two numbers are given. You have factorized. I will show you. You have factorized, okay, by prime factorization method and expressed as a power of prime, and you find out the smallest power of each common prime factor in the numbers, okay, in the numbers, okay, in the common prime factor in the smallest power of each common prime factor in the numbers. This is for HCF, highest common factor. Highest common factor also known by the name GCD, greatest common divisor, or highest common factor. Now LCM, lowest common multiple, LCM. Now what will be the LCM? Product of the greatest power, here the smallest power, here the greatest power, okay, of each prime factor involved in the numbers, okay. Here common smallest power, okay, prime factors, okay, of the smallest power of the prime factors, common prime factors, and here greatest power of each prime factor. Here that common word is missing here, you see, common word is not there. Product of the greatest power of each prime factor involved in the numbers, okay. So this one, from understanding these two, you can find once again HCF, product of the smallest power of each common prime factor, and LCM is the product of the greatest power of each prime factor, all involved in the numbers, okay. Now remember it, and I am going to take two numbers, and by prime factorization or by using what is called fundamental theorem of arithmetic, we will find the HCF and LCM. Let us take two numbers. Say suppose, let us take these two numbers, 6 and 20, okay, 6 and 20, okay, 6 and 20, all right. Now 6, you factorize 6, you know, prime factorization 2, 3, so 2 into 3, okay, 2 into 3 is the 6, you can express as 2 into 3. Now 2 is coming 1, so let me put a power 1, 3 also power 1, okay, and 20 also I express as a power of prime. 2 and 3 are primes. 20, 2, 10, 2, 5, okay. So now 2 to the power 2 into 5 to the power 1, 2 to the power 2 and 5 to the power 1, okay. Now HCF. So therefore, you'll first find HCF. The numbers are here 6 and 20. 6 and 20 equal to. Remember the process. Product of the smallest power of each common prime factor. Smallest power of each common prime factor. Now here common prime factor you can see 2. Common prime factor is 2 because there is 2, there is 2. But there are, in this number 2 2s are there. Means power of 2 is 2. Here power of 2 is 1. But the process says the smallest power, the smallest power is 1. If we compare the powers here 1, here 2, so smallest power is 1. So that means 2 to the power 1, that is HCF is 2. For 6 and 20 it is 2. Then LCM, and LCM of 6 and 20 equal to, remember the process, product of the greatest power of each prime factor. Greatest power of each prime factor. So here prime factors are, in both the numbers, prime factors are 2, 3 and 5. So if we take the greatest power of 2, then we will take 2 square into greatest power of 3. Here you have only 1 3 and power is 1. So 3 to the power 1 and another, that is 5 to the power also 1. So that means 2 to the power 4. 2 is 4 into 3 into 5. Now multiply 4 5s are 20, that is 60. Okay, once again, any two composite numbers I have taken for example. Okay, this is an example, means example. So what will do? These two numbers, composite numbers given to you, you are going to find the HCF and LCM. The process I am explaining here. You factorize the numbers. Okay, by using prime factorization method, means you will be using only prime numbers. You should know prime numbers. I told you prime numbers. Okay, by prime numbers. Then express each number as a product of the primes. 6 as a product of these two primes, 2, 3 with power. Okay, power here means how many times they come. Here 2 coming 1 time, so power is 1. 3 coming 1 time, so power is 1. In 20, 2 is coming 2 times. You can see, so power is 2. But 5 is coming 1 time, so power is 1. Alright? So then HCF, when you are finding HCF of 6 and 20, okay, smallest common prime factor with the least power. Okay, so smallest, here common is 2. Okay, so this prime factor common is 2 and power, the smallest power, not 2, power 1 is smaller one. Okay, smaller one is the common one. You see, if we take the 4 cannot divide 6, but 2 can divide 6. 2 can divide 20, 2 can divide 6. Okay, but if we take 2 to the power 4, it will be 4 cannot divide 6, although 4 can divide 20. 4 can divide 20 because 4 is a factor of 20, 2 to the 4. Okay, so that's why here smallest power. But when you are finding LCM, lowest common multiple, say of 6 and 20, you will go for the highest power of all the prime factors for both the numbers. So highest power here common, 2 is common, so but its highest power is 2 square, so 2 square. And 3 is alone with power 1, highest power 1, so and 5 is power 1. Product of all of them, multiply all of them, whatever it comes. Now you see, 6 can divide 60, 6 10s are 60, 20 can divide 60, 23s are 60. Because multiple, a multiple is divisible by its factors. That means in this case, 6 and 20 are factors of 60, factors of 50. And here 2 is the factor of 6 and 20. See the difference. 2 is the factor of 6 and 20. Yes, here 6 and 20 are the factors of 60. Because they can, that's why this is a multiple and this is a factor. Okay, I hope it is clear.